Well, good morning, everybody. Today we're going to take a look at, again, vector operations, which we started the other day. We're going to use Pythagorean theorem, and we're also going to use the tangent function to kind of help us find the resultant magnitude and direction. So we're going to start off with this problem right here. All right, so grab your pen, paper, notebook, write these things down so you can follow them along later when you have to sail by yourself. Okay, so we have an archaeologist who climbs the Great Pyramid in Giza, Egypt. The pyramid's height is 136 meters, and its width is 2.30 times 10 to the second meters, which is 230 meters. Question is, what is the magnitude and direction of the displacement of the archaeologist after she has climbed from the bottom of the pyramid to the top? Well, we're going to approach this like we do every other problem. We're going to extract the given information and we're going to apply it to a picture. So let's go ahead and take a look at this. Right here we go. Okay, so we know that the height of the pyramid was 136 meters, so that would be the vertical displacement, or delta y. And she's going to be climbing this pyramid. So if she climbs this pyramid, she's not going to go up and then come back down for the whole width. So that's why we take half of the total width of the pyramid. So the horizontal displacement that she's going to take is 115 meters instead of the 230 meters. Okay, so now we have a vertical displacement and a horizontal displacement. Our question mark wants us to find the displacement, the resultant displacement, and the direction, the angle with which she's climbing this pyramid. Okay? All right, let's start working this out. Okay, to do this, we're going to use Pythagorean theorem. The displacement, the resultant displacement squared, is going to be equal to the horizontal leg squared plus the vertical leg of this triangle that we've drawn on the previous squared. And the tangent function, which we already know, tangent of angle theta is equal to opposite over adjacent, which in this case is the vertical displacement divided by the horizontal displacement. All right, so to isolate the variables we have here, we're going to take the square root of both sides, and that gives us our resultant displacement equal to the square root of the horizontal displacement squared plus the vertical displacement squared. And angle theta by itself we get by taking the inverse tangent, or dividing tangent to both sides. And we've got the inverse tangent is equal the inverse tangent times the vertical displacement divided by the horizontal displacement. Now let's take a look at this with the numbers plugged in. All right, to calculate, we're going to plug and chug the numbers. We've got our displacement is equal to the square root of the horizontal displacement of 115 meters squared plus 136 meters squared equal to 178 meters. Okay, what I want you to do right now is pause this, get out your calculator, do this calculation. If you do not get 178 meters, there's something wrong with how you're putting it in the calculator. We've got to reach the bottom of this. So what you need to do is go talk to Mrs. Parson, go talk to Mrs. Witt, see what it is that you're doing to make sure that you're getting the math part right. Okay? All right, moving on. Now to find angle theta, we plug in the numbers that we have previously, the inverse tangent of the vertical component, which is 136 meters, divided by 115 meters. And angle theta will be 49.8 degrees. Now, again, pause this. Make sure you get the math right. If your calculator is in radian mode, you're not going to get 49.8 degrees. So check that, make sure you have it in the correct mode. All right, moving on. Okay, next, resolving vectors into their components. We've already done this, but this is a nice little quick quick review. Okay, so we can often describe an object's motion more conveniently by breaking a single vector into two components, or resolving that vector. That's what it's called. The components of a vector are the projections of a vector along the axes of the coordinate system. And by doing this, resolving a vector, we can analyze the motion in each direction, the x and y directions. Now here's some example information. If we consider an airplane traveling at 95 kilometers per hour, the hypotenuse, or the velocity of the plane, is that resultant vector. So we see it down here in this picture. and that describes the airplane's total velocity. The adjacent leg represents the x component right here, Vx, which describes the airplane's horizontal speed. The opposite leg here, Vy, the y component, describes the vertical speed. Now this is where we start using these other trig functions, the sine and cosine functions, which can be used to find the components. The sine and cosine functions are defined in terms of the lengths of the sides of a right triangle. All right, remember SOHCAHTOA, SOH, okay? Sine of angle theta is opposite over hypotenuse. That'll get us our opposite side. And cosine of angle theta is adjacent over hypotenuse to get us our adjacent side. Okay, so let's suppose here that a plane travels first 5 kilometers at an angle of 35 degrees, then climbs 10 degrees for 22 kilometers as shown in this picture below. How can we find the total displacement? Well, because the original displacement vectors do not form a right triangle, we cannot directly apply the tangent function or Pythagorean theorem. So what do we have to do? We're going to have to resolve each of these vectors into their components, and then we have to add all of their components together to get us a right triangle. So let's take a look at that. Okay, so we find the magnitude and direction of the resultant by resolving each of the components, vectors into their components, and then the components along each axis can be added together. So for vector number 1, we've got its x component right here, and its y component right here. So what we did was that its y component is actually here, but we move it out here so it is parallel with, and it lines up with the other one. For vector number 2, its x component actually is right here, but we moved it down so we can add it to the first one. And then the y component number 2 is right here, right where it stayed. Okay? So look here, if we add all of these total x's together, that makes a leg of a right triangle, and then these y components, add them together, that makes the other leg of a right triangle. And here, this from beginning to end, this is our displacement, that would give us the hypotenuse of our right triangle. And we can use Pythagorean theorem and the tangent function to find both the magnitude and direction of this particular resultant. Okay, so now let's take a look at a sample problem. We're going to go through it quickly, and hopefully this will help you be able to get some of those practice exercises that were assigned to you the other day done. All right, here we go. Okay, so here we go. We got a hiker who walks 27 kilometers from her base camp at 35 degrees south of east. South of east. Okay, so if we take east, east is like the x-axis, take it south. Oh, this is going to be an angle underneath. Okay, next day, she walks 41 kilometers in a direction of 65 degrees north of east and discovers a forest ranger's tower. What we're going to do is find the magnitude and direction of her resultant displacement. All right, so we need to write all this stuff down, the 27 kilometers at 35 degrees south of east, and the second displacement of 41 kilometers at 65 degrees north of east. And we're going to start analyzing that information. Okay, here we go. First things first is to select a coordinate system and then sketch and label the vectors. So our first vector, displacement number 1, is 27 kilometers at an angle of negative 35 degrees. What? Negative 35 degrees? Well, let's take a look at this. If we draw this and the x-axis is east, and it said that she traveled south of east, so south would be directly down, right? So this angle is coming from east and then moving south at 35 degrees. So angle of theta 1 is actually a negative 35 degree angle. Now why is it negative? Well, this is in the fourth quadrant, right? So this is in the fourth quadrant. So we got negative, we're negative in the vertical direction here. So that's why it's a negative 35 degrees. If we wanted to do the whole global angle issue, we could come all the way around to have a positive angle. But I don't think we want to mess with that right now. Okay, so our second vector, vector number 2, displacement number 2, we draw from the tip of the first vector, and it says that she traveled 41 kilometers, right here, that's the magnitude, and then at a direction of 65 degrees north of east. So this little dotted line, this is like another east facing direction here, and we draw it from there. North of east means we're going 65 degrees from east in the north direction. So that's why theta 2 is drawn that way. All right, so our unknowns are, we're trying to find the displacement from beginning to end, see how it's drawn there, and we want to find this angle theta right here. In order to do that, we are going to resolve both vector number 1, displacement number 1, and displacement number 2 into their x and y components. Okay, so this looks like a mess, a lot of writing, but we're going to go step by step through it. Hopefully I have enough time. Okay, so it's always good for us to take each displacement by itself, draw it by itself, resolve it into its own individual components. So displacement number 1, we have 27 kilometers at an angle of -35. To find the x component, it is going to be adjacent, so we're going to use the cosine function. Okay, so we plug and chug the numbers. We've got our hypotenuse of 27 times the cosine of -35 degrees. Make sure your calculator is in degree mode. That's equal to 22 kilometers. Okay, to find the y component here, we're going to use the sine function. So we would have our hypotenuse of 27 kilometers times the sine of -35, and that's equal to -15 kilometers. Okay, for day 2, we have this vector, and it's at an angle of 65 degrees north of east. Plug and chug your numbers. The x component is equal to 41 times the cosine of 65, and that's equal to 17. The y component is 41 times the sine of 65 degrees, and that should give you 37 kilometers. Again, if you don't get the same numbers, check your math. Make sure you're putting the stuff in the calculator right, because that could be the biggest issue that you face. Maybe you're setting it up right, you're just not doing the math quite right. Ask for help. Get help from somebody who knows what they're doing, or you can talk to one of your teachers. Okay, to continue work this out. To find the x and y components of the total displacement, you are going to add together all of the x's. So we have 22 plus 17 kilometers to give us 39 kilometers. And you're going to add the total y's. You're going to take -15 kilometers plus 37 kilometers to give us 22 kilometers. Then we use Pythagorean theorem to find that resultant displacement's magnitude. So we plug it into Pythagorean theorem, where the displacement is equal to the square root of the total x's squared plus the total y squared, which gives us an answer of 45 kilometers. If you do not get this answer, check again. Make sure you put it in the calculator right. Okay, and lastly, to find the angle or the direction of our resultant displacement, we use the inverse tangent of opposite over adjacent, and this would be our total x's and total y's. So we take the inverse tangent of our total y's, our y components added together, divided by our total x's, our x components added together. And we should end up with an angle, positive angle, of 29 degrees, which gets us north of east. Okay, so take a look at your practice exercises that you were assigned the other day. See if you can apply this information. Your teachers will be around to help you. Please feel free to ask questions if you don't understand. And if you have to ask the same question 20 times until you understand, keep asking it. No question is a dumb question when it comes to these problems, because they're just flat out difficult. Okay? Take your time, take deep breaths if you need to. You're going to get this. All right, we'll see you guys later. Take care. Bye-bye.